Welcome back to our exciting journey through the cosmos. In this second episode of our series, we will dive even deeper into the wonders of the universe. Have you ever wondered what happens when a star reaches the end of its life? Today we will explore these dramatic and awe-inspiring events. Then we will turn our attention to even more interesting astrophysical objects, the fascinating remnants of supernova explosions that challenge our understandings of matter and gravity. I would like to thank all our subscribers who have made the first video successful. Also, at the end of this video, at the end screen, you will find an enriching podcast on astronomy and astrophysics with Professor Abhirup Datta, Professor and Head of the Department of Astrophysics at IIT Indore. My name is Shaunak and you're watching this video on my channel, Physics for Students. Welcome to the Basic Concepts of Astrophysics, Episode 2. So in the last episode, whatever we have discussed here is a very quick wrap up, and I'm putting up the details of that video in the I button so that you can check it up. So in the last video, what we covered is what is a planet and a dwarf planet. We dealt with the relationship as well as the differences. I also covered black hole and neutron star. You also learned a lot about dark matter and energy. Most importantly, a mathematical concept called Eddington limit and Chandrasekhar limit. And we also saw with few examples what is a redshift and a blue shift. So in today's video, we will start first with a wonderful concept which is called what is a supernova and what is a hypernova. Now, the concept and the word nova is actually coming from the Latin word novus, which means new. As in English we know innovate, renovate, novalia, all these are actually coming from the same word nova, which actually means new. So you can say supernova means super new and hypernova means something which is very new or something like that. So a supernova, as you can see, is a powerful and a luminous explosion of a star. So a supernova occurs during the last revolutionary stages of a massive star. So supernova happens when a massive star, which is obviously several times than our mass of the sun, runs out of its fuel and its core collapses under gravity, igniting a violent outward explosion. What also happens is that when the supernova happens, the star sheds out outer layers, leaving behind a neutron star or a black hole, and it depends upon what type of star formation it is. Supernova can also be divided into two broad classes, type 1 and type 2, according to the way in which they detonate. So, and it is classified into different type based on the composition, which means the presence of hydrogen. So in short, we can say that should be several times more than the mass of the sun. It would collapse and it would lead to a very violent ignition and about its classification. Now, when we come to the concept of hypernova, obviously it is extremely energetic and it is more than what is a supernova. It occurs, as you can see, I have written that much more massive than the typical supernova. That is, it should be greater than 30 solar masses, and that is huge. The collapse likely forms a rapidly spinning black hole with ejecting powerful jets. We will look into this jet or relativistic jet into this part of the video, and it releases 10 to 100 times more energy than a standard, I would say, supernova, and it may or may not be associated with a gamma ray burst. So from here what we understand that obviously hypernova is much greater, much bigger, and it would require a mass of a star which should be more than 30 solar masses, and it releases 10 to 100 times more than the release of supernova. So here is a quick, you can say it is a distinction or a relationship. So first is that powerful stellar explosion, obviously, and which is on a standard scale. This is much more energetic of supernova, like a supernova on steroids. It releases less energy compared to that of a hypernova, and here you can see hypernova releases 10 to 100 times more energy. Supernova can occur in stars several times the mass of sun, but it should be greater than or maybe equal to 30 solar masses. And the GRBs, that means the gamma ray burst, are not always associated, although it releases, supernova releases gamma ray, but it is not always. But this one is that these are the most powerful explosion, releasing incredible amount of gamma rays in short bursts, and that is why hypernova and supernova are quite visible in the night sky. Now, there is another important thing that which you might be thinking that, okay, regarding gamma ray burst, is this the final verdict? No, it is. So here is a quick note that not all hypernovae, I mean to say, which is a plural of hypernova, are necessarily associated with GRBs. The exact conditions, I mean to say, when hypernova produces a GRB is still under investigation. Some factors, obviously, like the specific angle of the relativistic jets or the surrounding environment, might influence a gamma ray burst. Hypernova are a promising candidate for explaining long duration of gamma ray bursts. So, I mean to say, if you see a long gamma ray burst, that means definitely it is associated with hypernova. But the exact condition is still under research, and more research is needed to fully understand and the connection and the specific conditions required for a GRB to occur within a hypernova. So yes, it is definitely under investigation, but it is a promising candidate, and it releases much more GRB than compared to that of supernova. What is the importance in terms of astrophysics? Let us quickly look into it. First is that it leads to what is called one thing which I have actually ignored is the galaxy formation. So yes, it helps in the formulation and evolution of galaxies, and also supernova are key players in terms of stellar revolution. Obviously, it helps you. Now here you can see I have given this periodic element terms of what is called gold and an iron. So contributes this it definitely contributes in providing more in terms of heavier elements, which are this, and supernova type 1a are actually used to measure, I would say, long astronomical distance, so that you can understand that how far the supernova it has happened. And this is important for energetic phenomena. It also is responsible for gamma ray bursts, black hole formation, and also it would help you to redefine the models of nuclear physics, so that because the core bursts and it releases gamma ray, so you can learn a lot about the new formation of the structures through nuclear physics. It helps in high energy processes and definitely what is called nucleosynthesis. So this is something which is important, but far more than importance are the researches which are going on in supernova and hypernova. Here you can see that it helps in the formation of galaxies. So the evolution of galaxies due to the role of supernova is something which is an important factor in the research. It contributes to understand the environments conducive to life by studying the distribution of elements like carbon and oxygen, and this is called astrobiology. Provides natural laboratories for studying the laws of physics under extreme conditions such as high energy and density. Natural laboratory in the sense that high in released energy that can be considered as a laboratory, and just as a meteor, when it falls, we take it down to the laboratory and study what are the elements and from where it is came, what is the galaxy, etc. So definitely it helps in understanding the fundamental physics, and I would say supernova observations contribute to the study of dark energy and the universe accelerating expansion. So these are definitely some of the important part, that why do we study something happening far from here, and scientists are very busy in studying that. Obviously there is a reason. So this clearly lays out the reason of studying the supernova and hypernova, including astrobiology, expansion of universe, study of elements, redefining the nuclear physics, and so on. We come to another very important concept which you might know, which is in astrophysics, which is okay. So yeah, so this one is also that it provides clues about the formation of black holes, because we have seen that hypernova and supernova actually form spinning black holes, so we can study the formation. So the next thing which comes very important is what is a gravitational lensing and what is a micro lensing. I understand that gravitational lensing is something which is very common. Here is a quick understanding of that. So gravitational lensing is actually a massive object or a galaxy cluster which bends space-time due to its gravity. What also comes here is that the light rays actually that passes the object are deflected, and it creates a distorted, or I would say magnified, images of objects behind. obviously that you can see the star which is right at the back of the space-time curvature. It can also produce a multiple stretched or brightened images of a single distant source, and this JWST telescope has given us a very good I would say views that it actually produces what you call the multiple images of the distant objects behind. It can also produce, used for study for the distribution of matter in the universe. It helps in mapping dark matter and observe very distant objects. So definitely gravitational lensing is a very important factor which helps us in doing and understanding things which are being bent, and we can see things which are going around. Now, on the other hand, there is something which is also called microlensing, and this is also important. So microlensing, you can say, it is a kind of a subset of gravitational lensing, and it focuses, as because the word micro you used, on smaller scale events which involve less massive objects. So if I go by the definition, you can say a weaker form of gravitational lensing caused by less massive objects than gravitational lensing for a planet. And the bending effect, as you can see, is much smaller, causing only a slight I would say brightening of a background star. And obviously it cannot be directly seen because the distorted objects is a temporary increase in brightness, so it cannot be observed. And why it is used for study? It is used to detect faint objects, for example exoplanets or a little bit of dim stars that would not be visible otherwise. So microlensing, I can say it is a little bit lesser than gravitational lensing. However, it is very important because some objects which are not heavily bent into space-time curvature, these things can also be seen. Now, here is a quick relationship between gravitation and microlensing. It is worth noticing. So, gravitational lensing deals with massive objects and strong bending due to visible distortions. This one is, basically less massive objects and weaker bending. It unveils the presence of distribution of dark matter because it is heavy, so gravitational lensing helps that. It allows observation of extreme distant galaxies, obviously, and it provides a naturally magnified glass for faint objects so that it moves around. On the other hand, you can see microlensing involves less massive objects, so it detects exoplanets, estimates the mass of unseen objects of black holes, and it also studies the distribution of star and matter within the galaxies. So that would be kind of a reverse thing. So microlensing and gravitational lensing, how it actually helps in each other. Now what we see is that there is another question that we call it lensing. So question is that why do we call it lensing? So we call it lensing because gravitational lensing is called lensing because it's similar to a conventional optical lens, but instead of using glasses or refracted lights, we use it gravity as comes as a glass, and it bends the path of light. So here is a quick understanding that the amount of bending actually depends on the shape. I mean to say, if you talk of the optical lens, on the material of the lens. Whereas here you can see that a massive object or I would say the gravitational lensing curves the space-time with its gravity, bending the path of light rays and nearby. Now this actually involves what is called a curved piece of glass that focuses or diverges light rays passing through it. And here what happens is the amount of bending depends on the mass of the object and the distance of the light ray from it. So from here what we understand is that the term lensing was adopted to reflect the analogous effect of light, even though the mechanism is entirely different. This is gravity, and this is what is called refraction. But that is a quick understanding that we call lensing. Why? Because it uses the same type of technology, but here it is a lens, and here gravity and the space-time curvature itself acts as a lens. Now we come to the next very important concept, which are called pulsars and neutron stars. I know that we have covered neutron stars in the earlier part of the video, but pulsars and neutron stars are a very important astrophysical concept, and most of the students, they confuse between them. So first we come to what is called a neutron star. Now you see, if I take the formation, the neutron star is incredibly dense, right? And the remnant of a massive star collapses after a supernova. That is what is called a formation. Now if I come to the composition, it is composed mostly of neutrons which are very packed. immensely packed, dense due to immense gravity. And if I come to the size comparison, you see that it is. So a neutron star is an extremely compact astronomical object with a typical mass exceeding that of the sun, but compressed into a sphere only about 20 kilometers in diameter, roughly the size of the city, which you can see the size of the city 20 meters, and that is the star size. So you can say this incredible density means that a single teaspoon of neutron star material would weigh around 1 billion tons on Earth. That is the beauty. That is how compact it is. And it has got a very hot and can have a very strong magnetic field. Now, if I come to what is called a pulsar is basically from why it is called pulsar, because it is pulsating radio source and is a highly magnetized rotating neutron star that emits beams of electromagnetic radiation and its magnetic poles. So in terms of formation, a specific type of a rapidly rotating neutron star with a very, very strong magnetic field. If I talk of the composition, it emits beams of radiation, radio waves, X-ray, gamma rays that sweep across the space like lighthouse beams of the star that spins. So you can see, just as a lighthouse spinning and sometimes the light is coming and hitting your eyes, this is also what the pulsars do. And if you talk of the rotation period, it can be incredibly short, ranging from milliseconds to seconds. And the pulsed nature of the emission arises from the magnetic field channeling the radiation beam. So we can see, that is the reason that we can see pulsars. So here is what we can call a relationship or the difference between them. If I go by the definition, it is a collapsed star of a massive star after supernova, and this is a type of neutron star emitting periods of radiation. Yeah, it may or may not be detectable radiation, but it emits beams of electromagnetic radiation, just like the lighthouse that we give the analogy. Now, it is not always detectable, but it is always detectable due to its regular pulsations. The rotations may have a rotation speed, rapid and regular rotation. Magnetic field have extremely strong magnetic field, and strong magnetic fields aligned with the rotational axis. And this is very, very important, that specific subsets of neutron stars, and all pulsars are neutron stars. So pulsars are actually all neutron stars. So that is why we call a type of a neutron star emitting radiation, but the neutron stars a specific subset of. So we can say that all pulsars are neutron stars, and these are specific subsets of what we call is of neutron stars, right? So these are periodic signals, precision time testing and relativity is done, strong magnetic fields aligned with rotational axis, right? And you can see that a type of neutron star which is emitting periodic radiation emits beam of electromagnetic radiation. All these things are taken into account. All these things are taken into account. And also important, it is detectable due to regular pulses. So this is what we call is that. Now the question is that nothing would go if there is no usage in terms of astrophysics. So if I take the importance of astrophysics, studying neutron stars are extremely helpful because it helps in the understanding of the behavior of matter of extreme densities and pressures. Also, you will see that it helps in testing relativity, because strong gravitational fields around around neutron star and the precise timing of pulsars provide tests for general relativity and other theories of gravity. It also acts, which I have not mentioned, that it acts as a cosmic laboratories, because neutron stars and pulsars serve as natural laboratories for studying fundamental physics. And insights into supernova and stellar evolution are basically gained through the study of these remnants. I mean, so this is something which is an astrophysical phenomena. What is also important is that I have not mentioned, it is called the equation of state, that is helps in understanding the equation of stars in ultra dense matter. You see here that neutron star mergers, I mean to say, when two neutron star merges, these are the source of gravitational waves, providing data for this field of study. Pulsars can also be used for precise atomic clocks or cosmic clocks, aiding in the measurement of distance and the mapping of the galaxy. Studies of binary pulsar system helps in understanding stellar evolution and the dynamics of binary star system. Very important, we start the binary stars. So the pulsars and the neutron stars, they all help. These are all helpful for studying astrophysics and understanding our universe better. We come to the next part, which is another important concept, which is called quasar and blazar. Now the pronunciation is not quasar, right? It is quasar, and this is considered as blazar, but not the blazer that you wear. So we first come to what is called a quasar. Now quasars actually are the remarkably bright cloud of active galaxies. So we call it the bright core, or AGN, that is active galaxy nuclei in the distant universe, and they are extreme form of what we call it as AGN. So if I go by the definition, extremely luminous object at the center of a distant galaxy, powered by a supermassive black holes actively accreting matter. And what is called accretion disk, we will discuss it later, but there is something which is called an accretion disk. I will come to that part later. It emits, if I talk of the emission, it emits vast amount of energy across the entire electromagnetic spectrum. If I go by the brightest object, yes, it is broad emission lines in the spectrum reveal the presence of rapidly moving glass around the black hole, and it can be visible over brightness in over time. If I come to what is called a blazar, you see that if I go by the definition, it is also a type of a quasar where the jet of material ejected from the supermassive black hole is pointed directly towards the Earth. And that is why you see that I have written in red that it is also a type of a quasar, but it is active galactic nuclei, but its relativistic jet is pointing towards the Earth. If I talk of the emission, the jet's Doppler effect amplifies the radiation we receive, making it appear far more luminous, and the blazar's rapid and dramatic variation is in terms of brightness, so the jet also contributes to the overall emission across the spectrum. So let us quickly see that the type of the quasar and blazar relationship. So here you can see I have just given this. This is basically an artist depiction of a quasar and a blazar. So blazars are what? Blazars are specific subtype of quasars which are extremely bright and energetic objects powered by supermassive black hole at the centers of galaxies. Second is that all blazars are quasars, but not all quasars are blazars. This is important. The key difference lies that in the viewing angle of the jet relative to Earth, and quasars can have jets pointed in any direction, while blazars have their jets pointed towards the Earth, making them appear particularly bright and variable due to what is called the relativistic effects. So this is a very important concept and very important for all of us to understand. And here is again a quick relationship and understanding between quasar and blazar. So we go by the definition. It is an extremely luminous active galaxy nuclei, which is abbreviated as AGN. Blazars are a type of AGN with a jet pointing directly towards the Earth. It emits electromagnetic radiation, including visible light, X-rays and radio waves, and this is the strong emission across the entire spectrum, including gamma rays. If I go by the energy emission, they're very high, but always extremely high energy emission. And visibility, it can be jet present, not always aligned to the Earth. And relation to jets, yes, the jet alignment is defining characteristic, means it's towards the Earth. Studying applications, probing distant universes, black holes and accretion studies. Here high energy precision intergalactic medium studies are also taken into account. And also what is important is this one, that if I consider the black hole studies, then quasars and blazars provide insights into the behavior and properties of supermassive black holes. What we see also is the studying these objects understand the roles of AGNs, that is active galaxy nuclei, and helps in the formation and evolution of galaxies. We also find important that blazars are definitely associated with high energy emissions and crucial for studying processes of extreme emergence energies and their relativistic jets. And yes, quasars serve as important tools for probing the distant universes, providing information around the early stages of what is called an cosmic evolution. We now come from the quasars and blazars to the last but very misunderstood and very confusing terms. What is a meteoroid? What is a meteor? And what is a meteorite? Three concepts, very closely English words, but they have got difference. We first come to what is called a meteoroid. Now these are small rocky or icy, I would say, objects which are orbiting around the sun. The size and range form a grain of sand to a small boulder and origin often remnants of comets or asteroids. If I talk of a meteor, then these are the visible streak of light produced when a meteoroid enters Earth's atmosphere and the friction with air molecules actually heats it up, and what is called a shooting star or a luminous streak of light is seen, and most meteors are completely vaporized before they reach the surface of the Earth. What is a meteoroid? A meteoroid is that which finally survives the passage through the atmosphere and impacts on the surface of the Earth, can vary greatly in size from pebbles to large craters, often offers valuable clues from the composition of asteroids, comets, and the, I would say, early solar system. So this is extremely important. So I can divide it in three phases, isn't it? The first phase is the starting form, where you can see that it is a small object in space. Then it comes to the contact of the surface of the Earth, and the visual phenomena is that the bursting streak into the atmosphere. And then finally when it lands, that is phase 3, the leftover piece, the objects that survives and lands finally to the Earth. So this is what is called the three terms meteoroid. First we see that meteor, which comes and creates that burning streak or a shooting star phenomena, and when it lands on the surface of the Earth, we'd call it as a meteoroid. So here is a quick relation between these three things. So first is that meteoroid exists in space until it encounters Earth's atmosphere. Meteor is a temporarily light phenomena within the atmosphere, and meteorite is finally which is touching the surface of the Earth. So let us quickly see what are the relationship and differences and so on. If I go by the definition, then I can say that meteoroid, a small rocky or metallic body in outer space. Meteor is a streak of light when the meteoroid burns in the atmosphere, and meteorite are the fragments that survives and hits the surface of the Earth. If I talk of the location, this is at outer space, this is at Earth's atmosphere, and this is on Earth's surface. The visibility not visible to naked eye. If I talk of this, if I talk of the size, yeah, it is varies from grains to meter-sized boulders, not available because it's a light phenomena, and it depends upon the surviving fragment. The phenomena, if I talk, it exists as a small object in space, light phenomena due to the atmospheric entry, and physical object which ultimately survives when it enters after it enters the atmosphere. If we talk of the observation, it is detected via telescopes and spacecraft, and this can be observed with the naked eye, especially during the meteor shower, and it studies in laboratories after collection to find out the chemical composition, etc. And this is studied for understanding materials in space. This is studied for atmospheric entry phenomena, and finally meteorite, analyzing the composition of the early solar system and so on. So this gives us a kind of a clear understanding of meteoroid, and what is a meteor. I hope this series is going fine with you, as I'm trying to clear up all those concepts of astrophysics before jumping into real astrophysical phenomena of mathematics and so on. So I am really thankful for those who have watched this video. So thank you very much for watching Physics for Students. If you like the video, please hit on the subscribe button and click on the bell icon to get all the notification from Physics for Students. You can write to this email ID, and you can subscribe to my other channel which is exclusive to General Theory of Relativity, and you can follow me on my Facebook, LinkedIn, Instagram and Twitter account. So Physics for Students will keep on surprising you with more such knowledgeable and interesting videos, and this series of astrophysics basics concepts will keep on going and going until we feel that yes, we have learned enough of astrophysics. But that would take time, and I will keep you surprised and feel you better in terms of physics and mathematics knowledge. So I will be back with few more videos and more videos, as I always promise and deliver. But till then, goodbye.